Hey there. In this video, we're going to do an example where we use the convolution theorem to find the inverse Laplace of a function. Here I have the function 1 over s squared times the quantity s squared plus 9. Now, we don't normally write a function, a rational function like this as a product, but here using the convolution theorem, it's going to help us out to do that. So I can rewrite this as 1 over s squared times 1 over s squared plus 9. Okay, because I'm doing a product, I don't need to worry about like partial fraction decomposition. I can just split them up like this. Okay, and so we want to take the inverse Laplace of 1 over s squared times 1 over s squared plus 9. And we can use the convolution theorem to help us out because it says that the Laplace inverse of a product is equal to the convolution of the Laplace inverse of each of those functions. So I can say, well, this is going to be equal to Laplace inverse of 1 over s squared convoluted with Laplace inverse of 1 over s squared plus 9. So what I'm going to do is I'm going to actually evaluate the Laplace inverse for each function separately, and then I'll use the definition of convolution to actually do the convolution of those two functions. Okay, so for this second one, the first one is going to match a formula pretty nicely from the table. The second one, I need to make one quick adjustment. Because I have s squared plus 9 in the denominator, I need to have a numerator of 3 since 9 is 3 squared. So I'm going to rewrite this one last time before I evaluate those Laplace inverse. Okay, and so I need a 3 inside, so I'm going to multiply by 1/3 out front to even that out. So I have 1/3 Laplace inverse of 3 over s squared plus 9. And now I can actually find the Laplace inverse of each of these. So for the first one, 1 over s squared, the Laplace inverse of that is just going to be t. And then convolution, and then 1/3. And 3 over s squared plus 9 is a sine function, so sine of 3t. All right, so looking better already. I'm in terms of t. Now I'll apply the convolution. And so that's going to be, I'm going to pull 1/3 out front of everything. And it's going to be the integral from 0 to t of tau. And you might call that tau. According to the internet, it's pronounced toe. I'm not Greek, so I'll go with toe, but I'm still getting used to it. So tau times sine of 3 times t minus tau. And we're integrating this with respect to tau. Okay, so there is using the definition of a convolution. And now I need to evaluate this thing. And I do have a product of functions inside of my integral, so I'm going to use integration by parts. So I'm going to use the tabular method. It works out nicely here. U is going to be tau, and dv is going to be sine of 3 times t minus tau. Okay, derivative of tau is 1. And with the tabular method, if you're not familiar, you're going to keep taking the derivative until you get 0. So derivative of 1 is 0. And now I'm going to integrate down the right side the same number of times. So the integral of sine is negative cosine. But using chain rule, I'm going to end up with a negative 1/3 out front. So that's going to be positive cosine of 3 times t minus tau. All right, and then the integral of that is I'm going to end up with negative 1/9, again from the chain rule, times sine of 3 times t minus tau. Okay, and so for the tabular method, you multiply the diagonals, alternating the sign plus, minus, and so forth. So the integral that I get is going to be the 1/3 out front times 1/3 tau cosine of 3 times t minus tau plus, let's have a double negative there, 1/9 sine of 3 of t minus tau. And our limits of integration are still from 0 to t. Okay, so I'll evaluate this at t. So that'll be 1/3 brackets 1/3 t cosine of, I'm going to have t minus t, so that's going to be cosine of 0, plus 1/9, and I'll get t minus t again, so sine of 0, minus, and now I'll plug in 0 everywhere. So this first one, tau is going to just make this whole thing 0 for the first term, plus 1/9 sine of 3t. Okay, so cleaning this up a little bit, cosine of 0 is 1, sine of 0 is 0. Okay, and so that's going to give me a 1/9 from this first term, minus 1/27 if I distribute the 1/3, sine of 3t. And there's my answer for that original inverse Laplace of 1 over s squared times s squared plus 9.